Hey everyone, it's Justin again. Today we're going to continue to add and subtract rational expressions. This time, we'll learn what to do when we have factored denominators. By the end of this lesson, you should be able to add and subtract rational expressions with factored denominators. For this lesson, we're going to complete 4 examples with a combination of binomial and monomial factors within denominators. Let's add the rational expressions with these factored denominators. In the denominators, we have factors of 3 and x plus 2, and in the other one, 4 and x plus 2. We want these to match, so we find the LCM of 3 and 4. The other factor was x plus 2, and both denominators already have that in common. So we multiply the first fraction by 4 over 4 and the second fraction by 3 over 3. This gives us our fractions with the same denominator. Now we can see our LCM of 12 times x plus 2. We add the numerators and we get our solution. All right, let's add these rational expressions with these factor denominators. In the denominators, we have factors of x plus 1 and x plus 4, and in the other one, x plus 3 and x plus 4. Once again, we want these to match, so if one denominator has a factor, the other one also needs to have that same factor. Both denominators have x plus 4, but the denominator on the right is missing x plus 1, and the denominator on the left is missing x plus 3. We distribute in the numerators and keep the denominators factored. We can see that the LCM of the denominator is x plus 3 times x plus 1 times x plus 4. Distributing in the denominator is not necessary, but this is what it would be if we needed to. You should go back and check this to make sure that you're able to do it if need be. Anyways, let's get back to the problem. Now we can add our numerators together to get our final solution. Now let's subtract the rational expressions in this practice problem. In the denominators, we have factors of x squared and x plus 3, and x plus 3 and x plus 2 in the other. Once again, we want these to match, so if one denominator is missing a factor that's in the other, we have to find a way to include it. Why don't you pause the video and keep going with this problem from here? Get as far as you can without help. All right, let's see how you did. Both denominators have x plus 3, but the denominator on the right is missing another x to create x squared. And the denominator on the left is missing x plus 2. We distribute in the numerators and keep the denominators in their factored form. We can see the LCM for the denominator is x squared times x plus 3 times x plus 2. We don't need to distribute in the denominator, but it would still be good to review and see if you could get this if you need to. Give it a try. This is what the denominator would be if we multiplied our factors together. Now let's get back to the problem. Now we can subtract our numerators to get our final solution. Let's subtract the rational expressions again here. In the denominators, we have factors of x minus 4 squared, which means x minus 4 times itself. And in the other one, x minus 4 and x plus 2. We want these to match, so we have to make sure both denominators include each other's factors. Pause the video now and try to finish the problem from here. Both denominators have one x minus 4. But the denominator on the right is missing that second x minus 4. And the denominator on the left is missing x plus 2. We distribute in the numerators and keep the denominators in their factored form. We could see our LCM for the denominator is x minus 4 squared times x plus 2. We don't need to distribute in the denominator, but if you want to see what it would be for practice, give it a try. This is what our denominator would be if we were expected to multiply those binomials together. We show an additional step here to make sure that we remember to distribute the subtraction through to the 3x and the negative 12. All right, Now we can subtract our numerators to get our final solution. Be careful with the numerator. We see that 2x minus 3x is negative x, and minus negative 12 becomes plus 12. Now you can add and subtract rational expressions with factor denominators. Remember, the denominators need the same factors, and we don't need to distribute in the denominator, but it was fun to do it a few times a day to keep our skills fresh. See you next time.
Hey.